Hello and welcome back, critical thinkers. Today's TEK is G4B. Identify and determine the validity of converse, inverse, and contrapositive of a conditional statement, and recognize the connection between a biconditional statement and a true conditional statement with a true converse. This video covers analyzing statements in if-then form. Our objective today is to analyze statements when they're in that if-then form, or perhaps even take a statement and convert it to an if-then form. And you will know you have mastered this objective when you can analyze statements in if-then form. You can determine the truth value of a statement. Every skill you learn in this video makes you a stronger problem solver and a better thinker. I know you can do this, so let's turn your practice time into your superpower. Let's begin with a definition. Our first definition is conditional statement, and that is a statement that can be written in the if-then form. So you need to have an if and you need to have a then. An example would be, if it rains this morning, then I will bring an umbrella. Notice I have my if and I have my then. We can also write a conditional statement using letters or variables, and we can do it like this. We can say P, then draw an arrow, and then put a Q. This right here, this symbol means if P, then Q. Whenever you see something that looks like this, it is a conditional statement. It's an if-then statement. It's just a shorthand way of writing it. Now, this P right here would be our hypothesis, and that's the phrase that immediately follows the word if. So if we're looking at our example up here, our hypothesis would be it rains this morning. Then Q is our conclusion. And it's the phrase that immediately follows the word then. So our conclusion would be, I will bring an umbrella. So for this particular conditional statement, we have an if-then. The words right after if form our hypothesis. The words immediately following then form our conclusion. Another example is down here. If a polygon has 6 sides, then it is a hexagon. So the words following the if are a polygon has 6 sides, so this is our hypothesis. And the words immediately following the then statement would be our conclusion, and it is a hexagon. So we have our hypothesis and we have our conclusion. Now, sometimes conditional statements are written without using the words if and then. And so what you have to do is you have to rewrite the statements, putting in the if and the then. But first you have to identify the hypothesis and the conclusion. And sometimes that can be tricky. Let's look at an example. So here's a statement. It says, a mammal is a warm-blooded animal. This is what we're working with. So what we need to do is we need to break this up into a hypothesis and a conclusion. So what I did was I took this statement and I said, an animal is a mammal, okay? An animal is a mammal. And then for my conclusion, I put, it is warm-blooded. So taking this statement, I rewrite it using if and then, stating if an animal is a mammal, then it is warm-blooded. Now take a look at this and see if this makes sense. Okay? Now moving along, the hypothesis and the conclusion have what we call truth value. All right? And the conditional statement in and of itself has a truth value. Okay, so the hypothesis has a truth value, the conclusion has a truth value, and the conditional statement has a truth value. So that means that the hypothesis can be true or false, the conclusion can be true or false, and the entire conditional statement can be true or false. And so let's look at another example. If Mary finishes her homework, then she will watch a movie. Okay, so what we're going to do is we're going to look at truth values for the hypothesis, the conclusion, and the total conditional statement. The easiest way to work with truth values in regard to a conditional statement is to build a table. And so that's what I did here. I built a table with 3 columns, hypothesis in the first, conclusion is in the second, and then the entire conditional statement is in that last column. Now, our hypothesis is Mary finishes her homework. The conclusion is she will watch a movie. The entire conditional statement is everything that's written here. And so I assigned variables to each part of the conditional statement. So the hypothesis is P, the conclusion is Q. So that means the conditional statement is if P, then Q. So let's look at this, breaking it down step by step. It's a little different than working with conjunctions and disjunctions. So you just have to pay attention how we work with conditional statements, all right? So I know that if Mary finishes her homework, she gets a T. If Mary finishes her homework, she gets a T. If Mary does not finish her homework, she gets an F. That's for false. If Mary doesn't finish her homework, it's false. The hypothesis becomes false. So therefore, let's look at the conclusion. So Mary finishes her homework. She does watch a movie. Then the conditional statement becomes true. If Mary finishes her homework, but she decides not to watch a movie, then this particular conditional statement becomes false. Mary does not finish her homework. Mary does not finish her homework here. It turns into a different situation because this conditional only deals with Mary finishing her homework, okay? So this is a special situation right here where the hypothesis becomes false. So let's focus on these 2 situations where Mary does watch the movie after she finishes her homework. So if Mary finishes her homework and watches the movie, of course, the conditional is going to be true. Now, if Mary does not watch a movie after she does her homework, then she has not basically fulfilled her promise. And so the conditional statement, this conditional statement, becomes false in this situation. But I also want to emphasize this right here. Look, a conditional statement is false only when its hypothesis is true and the conclusion is false. So here we have a true hypothesis and a false conclusion, okay? And that turns this into false. Now, looking at when Mary does not finish her homework right here, this is a unique part of the conditional because it's not covered by the initial conditional statement. We're assuming that Mary finishes her homework, and when she doesn't, different things happen, okay? So I want you to look over here. I wrote down what's going on in these 2 situations. Now, the conditional only indicates what's going to happen when Mary finishes her homework. She could watch a movie or not watch a movie if she does not finish her homework. So I want you to notice that when a hypothesis is false, so here is our false hypotheses, the conditional will always be true, okay? Regardless whether the conclusion is true or it's false. So when you're figuring out the truth value of a conditional statement, if the hypothesis is false, you automatically know that the conditional statement is going to be considered true. Now let's work on a problem together. The problem reads, determine the truth value of the conditional statement. If true, explain your reasoning. If false, give a counterexample. So the situation is this. If you divide an integer by another integer, the quotient is also an integer. Okay? So if I go through some different examples, so if I divide, let's say, 2 by 1, they're both integers. 2 divided by 1 is 2. So all three of these are integers. If I take 2 and divide it by 2, I get a 1. So all of these turn out to be integers. But what happens is if the numerator is smaller than the denominator, so like if I get an example like 2 over 4, both of these are integers. 2 over 4 can be reduced to 1/2, which is 0.5. 0.5 is not an integer. So I know that this statement right here is not true, okay? The conclusion is false. So what happens is this. I'm going to come up with a counterexample that proves that this statement is false. So I'm going to get 3, and I'm going to divide 3 by 5. So I know if I take a calculator and I divide 3 by 5, or if I divide it longhand, I get 0.6. This is not an integer. So this right here is my counterexample. 3 divided by 5. They're two integers, but they produce a decimal number. Since 0.6 is not an integer, the conclusion has to be false, okay? Since a counterexample exists, then the conditional statement is false. With this, we answered the question. If it's true, we explain our reasoning. If it's false, we need to give our counterexample. Here's our counterexample, and in addition to it, I explained it. Now it's your turn to take the lead. Let's see how you can apply what we have just covered in regard to conditional statements to this specific problem. The problem reads, determine the truth value of the conditional statement. If true, explain your reasoning. If false, give a counterexample. Now, here's the conditional statement. If a triangle has 4 sides, then it is concave. Okay, I'm going to read it again. If a triangle has 4 sides, then it is concave. So I want to draw your attention to this word concave. When we used concave, we were talking about regular polygons previously. And so a concaved polygon is one that falls into itself. Do you remember the opposite of concave? It was convex, and that's what makes a regular polygon if it's convex. And so concave means it falls into itself. It's not puffed out. So with this, please remember to answer the question. If you have any issues or questions, please ask for help. Look back to the previous example if you need some guidance. You may check your answers on the next slide. So please pause the video now and complete your work. And when you're finished, press play to continue. Here's the answer to our problem, guys. Please pause the video and check your answers. When you're finished, press play to continue. This is it for today's video. We really did do some great work today. If something doesn't make sense, though, it's your cue to ask questions. In fact, it's your responsibility to ask questions. Now, you can come talk with me, you can talk with your classmates, you can even talk to your shoulder partner, even try AI, using it for step-by-step explanations. And please remember that we're a team here, and we're all here to help one another succeed. You learn best by breaking complex concepts down into smaller, more manageable skills. And that's exactly what we did today. You are turning your practice time into a superpower. Now, I believe in you, and I know that you can do this. You are working your way to success, learning one skill at a time. I want you to have a great day, and thanks for working with me.